Right, in this video, we're going to prove the Pythagorean theorem using our whole geometric mean construct. And so given right triangle, we'll call it ABC, with right angle C, prove A squared plus B squared equals C squared. Okay, so what we're going to do is we're going to draw an altitude to the hypotenuse, breaking it into two segments. We'll call this one X and this one Y, C being the entire hypotenuse. Writing down the given. To draw C, let's just call this M. Breaking the hypotenuse into two segments. I'm labeling the segments with one letter instead of two because it just makes everything so much easier to see. If you remember how to justify this, we know that there is a unique perpendicular from any point not on the line, and we learned how to construct it. There exists a unique perpendicular from any point not on a line. Okay, so now that we have this set up, we can do our nice geometric mean. We're not going to need to do the altitude geometric mean because we don't want nor need to use the altitude. We're trying to prove A squared, B squared, and C squared all around the periphery of the right triangle, the legs and the hypotenuse. So we're going to stick on those periphery things, which means we're going to be doing leg geometric mean. So since we've already derived that, we don't need to prove it. We're just going to do it. So A is the geometric mean between X and C, the adjacent segment and the entire hypotenuse. And similarly, we got to get B in here somehow and see how our A squared and our B squared are going to come about by cross multiplying those. So B is the geometric mean between Y and C. So I'm going to write leg geo mean theorem. I'm going to run out of paper. That's okay. Step 4. I'm going to cross multiply those. Don't even need the picture anymore. A squared equals XC. B squared equals YC. Cross multiplying. Property of proportions. Okay. Now, since I have two equations, I can add them together like a linear system. If you add equals, you get equals. That's addition, property of equality. So since those are equal, I can add them to both sides of this equation and get A squared plus B squared equals XC plus YC. Addition, property of equality. You can use it to add the same thing to both sides of an equation or equal things to both sides of an equation, something that often gets skipped. Now, step 6. I don't know if you see where we're going here, but this is great. We got the A squared plus B squared. We just need to somehow make this C squared. If you look back at the picture, it is true that X plus Y equals C. So if I could make that say X plus Y, I could substitute a C in by segment addition. So I'm going to take this out. I'm going to take a GCF of C out, which is distributive property, and rewrite that as X plus Y. So I'm going to say that is distributive property, and then you could put GCF in parentheses, somehow communicate that you know what that is. You don't have to write both those. One or the other would be fine. Now I know that X plus Y equals C. by segment addition postulate. So I can substitute that in. I'm going to rewrite that and say substitution. You guys like to write PLE, so I'll write that too. So a squared plus b squared equals c squared. I'll say definition of an exponent. That sounds good. Definition of an exponent, repeated multiplication. Maybe it's slightly different than the fill-in-the-blank one I got you in class, but the overall idea is the same, that you use like geometric mean, add them together, and see that you get a squared plus b squared equals c squared. One of the many, many, many proofs of the Pythagorean theorem. I looked them up once. There's like 50-something different proofs of the Pythagorean theorem. All of them valid, all of them good, but the Common Core requires that you know this specific one. So study it. The end.